Today the topic is the
This meeting is being transcribed and summarized.
Introduction to R. Some of you already know it and use it. Some of you maybe are using Stata if you visited some classes on research methods. And the R is just one of the alternatives, and which is open source. It means that it is free. So you don't need to purchase like a license for $200 for Stata just yearly. But there are also pros and cons. So pros are that it is open source, it is free, and it has a huge community that build different awesome packages. Those packages allows you to create beautiful tables, graphs, charts that you can directly put into your paper, and it will be like pretty. Or also you can organize them according to the journal where you are going to publish, so it will be more handy for you. And also and cons are, of course, that because there are a lot of libraries and different versions, sometimes there can be small differences in the results that you get because of the version of the package, which method of calculations they use, and so on. So generally, first step is how to install the R. There are two applications that you need to install. The first one is the R itself. R is the programming language, and this is just a shell. And of course, you can work directly with the shell, but some smart guys came up with the R Studio, which wraps this R programming language and creates you a beautiful integrated development environment or interface. So our steps, if you didn't install it, and for the record, I will show. So first we will start with installation, downloading and installation of the R. Here, as you can see, there are versions for all three platforms, Linux, Mac OS, and Windows. So you choose the appropriate one for you. And here we go with R for the first time, which downloads the binary here. Yeah, there are very many links to find the needed item to download, but in the end, yeah. So this is a small file of 86 megabytes. Then here we also download the R Studio, which is bigger, like around 300 megabytes. And also, as you can see, this version was released on 19th of February, which means they update like monthly. So you always like welcome to update it, although you can stay on the version that works for you. So yeah, after they are installed, you go first, you install the R, which is already installed for me. So this is just a standard process. After which you install the R Studio, which also goes through the installation wizard. Yeah, it is already installed for me. So if you are on your laptops, you can go back to this recording, pause it, and download and install all the things that you need. After which you find the R in your installed applications. I click Windows button and type the R, and it is there. Or you can write R Studio. So then we open it. In my case, it is already open. And here, what you get first. So we will need to get familiar with the interface. But before that, are all the previous steps clear to you? Do you have any questions? So basic steps, right? We have three main windows. We have this console where the output, like the R R itself is here. So you can directly work with it. You type R commands in R language, and it returns here. Then here, this part, the environment, or upper right section. Here is your environment. There will be your variables that we are working with, and you can briefly see what those variables contain. And here is on the right bottom. There will be your graphs if you generate them, and also here the folder system of the project where you are. So let's do the basic hello world as it is done in each language. So what we do, we say print, open the parentheses, open these symbols for the string variable, and say hello. So I hope it is visible. And then we enter, it just returns the hello. This is like basic interaction with the R language. Next step is, this syntaxes includes basic steps. One of them are, like in each language, there are things called variables. For example, A. So we can define any variable that you want. For example, A equals is the arrow. So arrow to the left, minus, and for example, 13. A is equal to 13. And what happened? We have a new variable, A, the value is 13. Then let's say B is equal to 24. And also we got the new variable 24, and we can also manipulate the variable using other variables. So B is equal to A multiplied to B. So basically we have a calculator here, first step. Then there are, like, what we are working with usually are the data sets. So data sets, like a lot of different numbers that we're working with. For example, let's say, let me test it. So also we can override it. A is equal to, for example, 1, 2, 3. Or this way. One second. There should be a way to define the array. C. So now I have overwritten the variable A to the set of numbers 1, 2, 3. There, what we can get, mean of A. So we can get the mean value of the A, or let's say this is about the GDP. Let's say it was, for example, 345 billion. Before that, it was 320, 310, 300. So let's say this will be our variable for the GDP for 4 years, four different years. How we can work with them? Well, we can get the mean value of the budgets. So, and the output shows the mean value of this data set. These are the basic manipulations. After that, we get to the real example from the work. So is this part clear, or like, is it unclear to you? Okay, I hope that you will be able to replicate it, but currently, no one just memorizes the syntaxes, right? We have the AI that will generate you what you need. So it shouldn't be a problem. I will just show how I do work with my current research papers. So the way how I found it should be convenient to work with. So first step, what I did, actually it was just yesterday. I was organizing my dissertation and I decided to make folders. 1 second. I will open the project. So here how the process looks like. I have a project. This is called the optimal bits replication. This is my paper where I replicate another paper. And what I do, first set the folder, working folder. And here is, so this is my working folder. Yeah, this one is a bit messy. So I start with creating scripts. How you create a script? You click Ctrl+Shift+N, and this creates a new empty script. And then you write what you need. Usually, how you go? You should select the folder where you are going to work. Here, you set the folder. Let me change the folder, for example. So here you see, with these 3 dots, you can choose the folder where you are going to work. Then you set it to the no, here, this is the project directory. And so move to the different folders to choose the folder where you are going to work. Usually you organize it beforehand in your like folder structure. So here, one of the examples of good folder structure as good, best practices. So I have a project. I have created the folder for the code. It can be either the like R, Python, SQL, with which I am working with. Then there is a data, like external processed raw, where I put the outputs like CSV files, maybe other types of files that I'm working with. Then there is a doc. Here I am working directly with the Word document, and also I can like put there. The R allows you to generate the Word document with a table, like beautified, formatted table according to the journal requirements. I will show that one a bit later. Then I have a folder for the literature. This is not that important. Then there is output. Here in this output, I put the tables, figures, models, and temporary. This is the structure I'm working with. So when you set the working directory, after you set it in your operating system, you can open it. Let's see this way. And then it will be initialized here. So this is your working directory. Then here you can, for example, select any file. And if it is readable, it will appear here. So I have clicked on the Readme MD and it opened here. So I can read the description, which is pretty useful. And it is also one of the good practices for you to first start with generating the Readme MD. This is a standard syntaxis where you describe what are your intentions and what are your main concepts you are working with, and so on. After that, you will go to the code. Yeah, I'm not sure. Yeah, I didn't create here any code. So this is organizing the folder structure for one project. So this is like initial part. Then I will get back to the ongoing project. So this project is, as I said already, the paper that I'm working on, but it doesn't have a perfect structure yet because I was creating a lot of scripts here and there. Only thing that I did, which I also strongly recommend, is to start creating scripts with names starting with like 01, 02, and so on. So you describe your steps and like after half a year, you can get back to the project. You can go to the first script, what it does. You can replicate, start again. Maybe your data has changed. Maybe you got like newer, more actual data. Then you can run it and process. So next thing is, here is the initial script. No, this one is the initial script. How it works? We have the syntaxes for installation of the packages. So it works like this. You can install a lot of packages or you can install single package like IDverse. Don't worry, it will be described by the AI that you are working with. So first step is to install the package that you are going to use. For example, let's say there is a library that lets you open the Excel files. So you will need to install the package that can open the Excel files. And after that, you will need to initialize that library. This is called by this function, library and the name of the library. And then they are stored to the memory of your computer and you can work with them. So here I will briefly tell about these libraries. Tidyverse is the library that works with data sets. It helps you like rearrange, reorganize them. Most of the models require this library. Then ggplot is for generating the graphs from your data, and so on. So now I will get back to my steps. What I was doing here. First step, I'm initializing the library reader. This one is able to read CSV files. And after I have initialized that library, I run this code. What I do here is I set to the df variable the content of this file, optimal number of bits 188. Here, my data set, which we can see here. Yeah, let's see it like in a Excel style. df. So here is my data set. What I have here? I have a like public procurements or tenders, year of the tender, procurement ID, tender date, yeah, and so on, and number of bids. How many participant suppliers wanted to win this procurement? You know, госзакупки, right? Where you can supply the government agency with some like goods, services, or works. So here the description of that data, and we have only 9 variables. Pretty easy, right? But its size is 29,000 records. So it means we have a data set like across years of different procurements. So what was the next step? Here, this library, Glimpse, what it does. Actually, like, it looks pretty similar to this one. Where you have a variable, you can extend the variable and see its first values here, like variable names and their contents. Or you can run the command glimpse df and get the similar manner. Maybe for some it is more convenient to work with that here. Also, this one is convenient for you to copy and paste to the AI. So you can show the AI, like here is the glimpse of my dataset, and it will describe you. For example, let's say I like to work with Claude AI regarding anything connected to the coding. I will create. I have this data set and want to find optimal number of bits as provided in the literature. Bits in public procurements. And here I describe it. The strongest model currently in coding is Opus 4.6. This is a paid account, but nevertheless, the free version, which uses Opus 4.5, is still very good because 4.6, it is when you are coding something extra, and and data is not so much extra, so it should be sufficient. So here, what it gives me next steps, what I need to do. And here it jumps directly to the solution, but I don't need the solution. Now I need to understand what I'm going to do. So first of all, I want to get the analytical part. So let's start with descriptive tables for the paper on data. Yeah, also it is better to be more precise what descriptive table you want to get. For example, if we look back to this data, how we decide? Let's see the years. We want to know what years are covered here. For that, we can start firstly with the summary of this years variable. This one gives us the summary of minimum, maximum, mean, median. So here we can see they are more or less equally distributed from 2022 to 2025. And also we can make a small histogram. Yeah, I will leave it as it is. Registry financial year and histogram. So,
Share your screen.
Sorry. So here, what we did and summary. DF financial. So this one is not needed. First, we run the glimpse into the data set. After that, we run the summary of the years, and in the end, we visualize what is the distribution of the years in the data set. So we can see there is a very small amount of data on 2022, and then more on 2023, peaked 2024, and 2025 is smaller. So based on that, we can do our inferences. And here it already knows the context of this data. Maybe it looked through the internet or the descriptions, and it has prepared for me the, yeah, this is really interesting part. Okay, let's see what we will get out of this. I will create new. So diverse GT. Here it will give you some warnings. This one is just a warning. This is not a fatal error. It says that the version of this library is for the older version of the R. Still okay, you can work with. The only problems can be like, because of the version, it will be if another person, or for example, your partner with whom you're working with, if he has different version, his output can be slightly different, but it is very rarely happens. Yeah, and this one is error. The library, there is no such library. Usually, how to install it? You just put the install packages and write the exact name of this library. And what it does, it directly goes to the internet and downloads this package. So it should take not more than 1 minute, I think. It is like installing from the App Store or Google Play. So it has installed. There are some errors, but let's test whether it will work. So we again try to initialize this library. And okay. If we have trouble, we can always copy paste the output here. So here I'm saying to the Claude that I have run this command and got this output. So he says I need to install this library instead first.
But Cloud Code is a different one, right?
Cloud Code is their sub-product. So the one you can install to your computer, and this is a terminal-based application. This is for coding, and usually it works great with like languages like Python and others. but I'm not sure, will it be connected to the R or not? So you will need to test. Also, there is a mode co-work where you can give him access to your computer and it will do everything on your computer. But you should be like aware that it can also accidentally purchase something with your card in your computer. So if you give the full access, there is an application called Cloud AI. Oh no, Cloudbot. Maybe a lot like there was a big noise around it. It can do everything on your computer, like full control. Cloud Code has a bit smaller control, but it has a mode that allows it to work with the folders and files in your computer, organize them, create, delete, and do everything else. So there you will need just to clearly prompt it what you need to do, and it will do that action. So the library is installed. We again try to initialize this GT summary library. Yeah, I forgot to mention, in order to execute the code by line, we go to that line. Then we click Control and Enter, or Command and Enter in macOS. So finally, it says only the warning that it was built on 4.4.3. Everything else is fine. So next step, what it does here, it transforms our data set. We get the new variable price ratio, which is equal to winning price divided to the estimated price, which is basic arithmetics, right? Then savings percent, here it is also 1 minus price ratio multiplied to 100. Also, we can understand it mathematically. Log value, here we transform log the estimated value. Then here is procedure type. Procedure type, there are like 2 and 3. It just knows it, but it isn't needed for us right now. So I can remove it because the data set that I have taken has only one method, so there is no differences. This one is interesting. I have a variable region Kato, Kato. And how it works? It is a hierarchical. First two digits, they represent the region, one of 20 regions of Kazakhstan. So 55 is like what it is. Let's see. Actually, it has made up the codes are incorrect. Yeah. Also, you need to be concise on the data set because here these katos are incorrect. 75 is actually Almaty, so I will need to fix it again. But nevertheless, here we have already the placeholders where we can put the correct codes. So we have the region categories, and then bidding groups were divided to the sections. In order to see why it is needed. Summary of DF number of bits. So we have number of bits goes from 1 to 50. And the mean is around 8. And if we look at the histogram, we have a lot of values that are very small. So it is distributed unequally. So what it suggests here is to move it to the categories, like bigger categories, so more or less equal groups. So let's run it. Yeah, so finally we understand what code was suggested. Let's run it. Okay, again, here's the error. Or I think we could go with for now, let's remove these regions because they're anyway incorrect. For us, it is sufficient to have this region. So here, will it work with the table 1? So this is the first table we are generating for our descriptive part of our report or paper. After we have transformed the data set, we are ready to execute this command. And we again got into the error, which we just copy to the AI. It says that we need more libraries, so let's install them. Okay, we will need to restart the R. Sometimes if the library is very big, then we will need to restart it. Yeah, I think I got a bit too deep. Here in the introduction part, I just wanted to show you the installation process and the glimpse of the workflow, how the process is organized. So one step that I wanted to do is to generate the Word document with the table, beautified table. So once I get there, I will do a quick recap so we can remember what steps we did. So 1 second. It was in this project, I think. Yeah, I think it is a little bit overloaded because of too many applications I have opened. Okay, so here, let's say we have already transformed all the variables that we needed. Then we go to the second section where we again transform the variables. Okay, I will need to activate all the libraries because after I turned it off, the libraries are detached. So I'll need to attach them again. Here, let's run this command, transformed. So we have our data set. Here I am generating the descriptive table. and here how it looks. So process type, number of lots, and so on. And then here, next step is beautify, save beautiful table that we can copy and paste to the Word document. So the next step is we use these libraries. Then the library GT that actually works, formats the tables. And one of the things that I got in the journals, there are requirements like you need 11 size font and so on. You will need the note in this manner here or up on the upper part or lower part. So here I generate this table. And it looks like this. So very professional, as you can see. Usually in the journals, they put it like this. You can just copy and paste the image like PNG, but I don't think that this is a good practice. So as a perfectionist, I decided to generate the docs and PANDOC document. Let's see what is the problem here. Oh, finally. So then in the end, the function that works to save the docx, not the GT, this was a mistake. It doesn't work. But the save as docx function, which is from one of the libraries that directly saves as the docx file. So we can find it here, table 2, summary by type. Oh no, it also got broken. Yeah, this is because of the table is too wide and it doesn't fit into the docx, but the general idea that you generate according to the formattings of the requirements of the journal, and then you run this command save as docx. So here, what is the idea? You basically know that there exists the function that can generate you the table in the docx format, and this will be a good table. So you can generate it and then copy and paste it to your Word, and you don't spend time formatting it. This, this is like final part why you use RStudio or R, and it saves you time. You will understand it once you spend a lot of time formatting and fixing the tables. Because even in in the process of working with the AI, its output, if you just copy and paste it to the Word, its format is broken, right? And this is one of the ways how to make it pretty and also directly connected to the data. So then if something changes in your data or you download newer version, you just go step by step again from your script like 01. You can run line by line, or you can select all of them and run the whole script at once if you are confident that everything is okay, there are no mistakes in your script. So yeah, finally, here is the main part, and maybe although it was first part of the introduction to R. I think I gave you everything I know. If like the next part will be just extension on the details, how to work, maybe like question answers on the real problems that you meet with after you practice with that. Yeah, and all my workflow on the data research is in the R. So what we did today is we have learned how to install the R. First, you need the R programming language. Then you need the wrapper of RStudio around that programming language. You install them one by one, and in the end, you get this window where the R itself is here. This console is the R's representation. You can work with it directly, like print hello. Also, you can create scripts and save these commands here and name them accordingly how you want them. And then you go line by line, put your mouse on the line that you want to run. For example, here, and you run Control Enter, and it is executed line by line. Or you can execute few lines if you select all of them, and they are simultaneously executed. After that, we saw the process of the libraries. With this command, you install the library. With this commands library, you run the library. You put it into the memory. You can see it as going to the App Store and downloading the application. And here, it is like you are running the application that you already installed. Next, here we activate the needed application, and then we run its command to read the data from the working directory. So here I'm working with a CSV file. It pretty obviously says read CSV, and it stores into the memory. Here, this is the representation of the memory of our R, and here we can see variables that are stored there. Then we can see what is inside of those variables by clicking on this triangle in the circle, and see what types of variable and so on. Then we have small commands like glimpse, summary, and histogram to build. Histogram is the simplest graph. There with the ggplot, you can create really cool professional graphs that you need. The only limit is your imagination, like what you want, or you look to the best practice and say, you just copy the screenshot this part of the graph that you got and say, I want to get similar with my data, give me R code. And then it will give it to you. And yeah, of course, you should also explain it that start with the requirements. What kind of data set should I have in order to generate such graph? And then, yeah, and then we got to the step where we generate the table with all the formattings. And in the code, you can see they are also self-explaining, because those are English words, like font size is 10, and so on. So logically, you can adjust every part according to your needs and generate the docx best for you. Yeah, so I think that's the final part. So sorry for being too, I don't know, maybe fast, rush, or nervous. It is first time for me doing the R introduction in the big auditory, because usually I work with a small group of master students where I go with them one by one. So they click, they get into the trouble, and I start fixing with them, explaining. So just telling it as a lecture, a little bit hard for me, because I don't get the instant feedback. So the real work starts when you start working with it and getting into the trouble, and we go together, like why you got to this trouble, how to fix it. But thanks to the AI, most like 90% of the troubles can be fixed with the AI, and 10% you will need some experienced person like me. So that's it from my part. Please, if you have, because we have 10 minutes.
But didn't have one question. So I've been grappling with this. Some of the basic stuff, like for example, a simple regression, you don't have to ask AI to write the code. You just give the data and just generates all the outputs without necessarily, we used to use our Stata to do that. Now then there is AI. You can ask AI to generate the code for Stata or R.
Yeah.
Now you can just throw it in there and it's going to give you the results. How much of what R can do can AI do without even going to R in the first place?
AIs cannot process data themselves, or you cannot trust how they process the data. Because this is LLM, this is just like has their hallucinations yet. Also, all of them currently operate with Python inside the AI, and they refer to that. But you cannot be sure whether it has downloaded the correct version of the data set that you have uploaded or else. So that's why you will need to ask him for the scripts, not for the processing the data. You need to you need to get the scripts so it is replicatable, and you can go and run it in different machine and different setup, and it will be the same. Because if you ask AI directly to process the data, it can give you different answers each time. This is the problem. Also, that's why you still need to operate with programming languages like Python, R, or Stata.
Okay. Maybe the next time, since you're doing this dissertation and you're finishing it up right now, for the next session, can you just go through putting the data with the analysis that you did, how you got the outputs, how you got the figure?
Actually,
this process.
Actually, I think that would be perfect for me as a clear deadline to do the work. Because I have a deadline of 15th of March for this work to do. So I will be really happy to share with you how I'm working with my dissertation. And I just got the perfect folder structure for the project. With each project I'm getting better, because on the first one of the colleagues showed me that this is one of the good ways how to organize your files, folders, data, and also we put it into the GitHub. So it is very convenient for collaborative work. Maybe we can cover it if you want on the next part, because this is also one of the things I believe important, and it adds the weight to your work. If you are able to upload your workflow to the open repository, and then you could put the link to that GitHub repository in your paper, the editors should they will be able to check it, at least test, run something, and your chances of getting published, I think, should grow. No problem. So that's it, guys. Thank you, everyone.